list than to look on here. Right. Because you have all those. But yeah, just count. Oh, you just count. Oh,
All right, guys. So, I want you to realize I like to do this kind of thing often where you have an exercise, you got to do the work, but I'm not going to grade this, obviously. I'm about to show you how to do it, so it's nothing I'm going to grade. You can make mistakes now, see why they're mistakes, and then not make the mistake on the quiz when it's going to be graded. So invariably, there's going to be things that I didn't realize I need to explain further or whatever. That's what I run into when I do this kind of thing. I say, oh, they didn't really get that. Okay. So one big thing is picking the method you want to use. Pick a method and stick with it. This method is in the book, but you do have to use these little extra outer, these are the limits, these are the boundaries. So there's no gaps when you graph it. All right. This way is nice, but it involves inequalities and x's, which for some reason people are scared of. But I understand. So you pick the way you like. Stick with it. So here I'm going to show you how to do both of them. The class width, what was it? 79 minus 62. Minus 62. And I said to use 5 classes. So 17 divided by 5 will be 3.4, which you round up to 4. Now, if you're doing it this way, it's kind of hidden a bit. Notice once I bring in the boundaries, then you can see the true width of the class. That's why this is always one less than you would think. So if I start at 62, and I know some of you didn't start at 62, but you can do that if you don't want to. I would suggest not to do that. The next one's got to start at 66, so I can see that they're 4 apart. But then this one's got to end where? 65, so that everybody's got a single place to go. I like it. So is this really 3? No, because it's 61.5 to 65.5, which is 4. So it hides it if you do it this way. That's why that second number is not what you would expect, because it's hiding some stuff. That's why personally I don't like it. Now, I'm not saying that to mean that if you do that way, I'm going to take points off, or I'm not going to like you as a person. That's crazy. You choose whatever way you like. Just personally, I prefer this way. It's like I don't like lima beans, stuff like that. Or if you love it, I'm not going to hate you. Yes?
For mine, my class width as 3.5. And it
yeah, okay. You could do that. I'm telling you, you're allowed to round to a nice whole number. You could round, but if you do round up always, so that you, like you guys were saying, you'd much rather have a shirt you can fit into. So you get the next size up. Whatever works. It's just like the wood paneling. If I didn't make them wider, if I made them smaller, then I wouldn't have enough pieces of wood to cover. If I make my classes smaller, I can't cover my entire data range. Whatever analogy you want to use. Whatever works, basically. So if I need to keep going by 4s, so here by 4s, I can just keep going by 4s down.
And you're
Bam.
not using your method.
Second?
You're not using your method here. Which method are you using here?
So yeah, so this is the way it would look if I'm using the textbook way.
Okay.
Here's how it would look. And it doesn't change the frequencies at all, depending on whichever way I choose to do it. This is the way it would look if I chose the inequality way. And this is a little bit better. You can see the 4 all the way through, right? You can do it, Jeff. That's exciting. Okay. So this one would just have on the scale of 62, 66. There's no need for an extra class boundary. The boundaries and the limits are the same. That's the way I was taught. That's the way I prefer. The other way, you do have to bring in that class boundary idea, just so there's no gaps, right? Okay. And then the frequency, this is always misunderstood too. It can't possibly just be like 3 or 4 for each one, because that's how wide it is. It's how many things fell into those classes. So how many, from 62 to 65, I only see 2, 62 and 64. Those heights fall in that class. That's how frequently something fell into that class. So that's got a frequency of 2. How about 66 to 69? 12. 12 people, 12 fathers had heights between those. 70, 73. 15, I like it. 74 to 77. 5 and 1. And if you add them up, thank God they add up to be 35. Thank you, guys. You always take that quick check to make sure you didn't miss anybody, or if you counted somebody twice, make sure it adds up to be the total number of data points. Good, good. Relative frequency, how do I get that? Yeah, 2 divided by 35 is about what percent? 5.7. 12 divided by 35. 34.2. 15 divided by 35.
42.8.
42.8. 5 divided by 35. 14.2. And then 1 divided by 35. 2.8. And if you add up those percentages, what'd you get? 99.7, roughly. And depending on how you guys round it or whatever, it might have been a little different. It's got to be close to 100. I'd say within 1% of 100. From 99 up to 101. Any more than that, and you might have rounded the wrong way, or maybe you did leave somebody out. Aw. And then for this one, cumulative frequency. And then you just add the next one. So it'll be 39.9, and then you add the next one. 82.7. Right?
Yeah.
And then you add the next one. And then you add the next one. I like it. So that's cumulative frequency. It accumulates as you go down. I like it. So again, sorry. So it starts at 5.7. And then this is going to be that plus this. This one's going to be all 3 of these. This is going to be all 4 of these. This is going to be all of them. So you accumulate as you move down the list. And then I want a relative. You got to pay attention. I might ask for a relative or just a straight up frequency histogram. Just tells you which numbers to use. I asked for the relative, so I want to use the percentage numbers. These guys. So I need to be able to go all the way up to 42.8%. So what scale should I use?
45.
Go up to 45 using 5? Sure. So let's see. 5, 10, 15, 20, 25, 30, 35, 40, 45. Let's see, relative frequency. I love you guys with the label on the bottom. I'll accept a few different variations, but basically just fathers' heights in inches from the 160 class. If you just put this, I'm happy. Now, the bottom doesn't have to reference the other axis at all. Fathers' heights, inches from the 160 class. And now I can go, for this one, I've got to use my class boundaries. Yeah, 61.5, and then I just keep adding 4.
Why are you using 61.5?
Because I did it this way.
Oh.
Now, if I did it this way, it would be 62, 66, 70, 74.
Oh.
Beautiful, fantastic. The only drawback to this, the inequality way, is you've got, it says 66 there in the first class, but you need to tell yourself they don't go in there because it's less than 66. That's the one drawback. Does that make sense?
So you only
I wouldn't include 66 in the first class because I only include those values that are less than 66. It goes in the next class, exactly. That's the one drawback. Everything else about it is better, in my opinion. And then finally, how tall is this first class going to be? Almost 6. Remember, I'm not using frequencies, I'm using relative frequencies. So the first class goes up to just a little above 5. The next one's going to go up to almost 35. And then up to almost 43. And then 14, just below 15. And then 2.8, roughly there. Would you say this is roughly normally distributed? Roughly.
It's a bell curve.
I like it. That's what normally distributed means. So normal distribution is starts low, goes high, goes low again. Now if it was perfectly symmetric, then I'd say it's approximately normal, not just roughly normal. This is roughly normal. Heights I expect to be normally distributed. So all it means is normally I expect to see some people that have heights around the average. Very few out here. So that's why I would have this bell curve shape to it. This is a sample from a sample. So it's not going to be perfect, right? I had 52 responses and I chose 35 randomly. Believe it or not, just randomly chose 35 and put them in there. Bam, bam, bam. And it came out roughly normal. It's pretty good. I like it. Okay. So any questions on this? This scale here would be, like I said, 62, 66, 70, so forth, if I did it with the inequality way. It's got some good advantages. But again, either way you do it, as long as you do it right, you're all going to get the same points for it. I don't play favorites. Oh, you used my way. Yeah. No, screw it. I don't care.
I have a quick question.
Yes.
So when you use the inequality rate, you still add 82.
Yeah, you have to see the 4, exactly. Be less than 82 at the end.
So that number you do add.
And that would be at the end, just like you got. Beautiful. I love it. Okay. All right. So how's that? Is that decent? Anything lingering about histogram stuff? Please let them be decently easy, because they are. It's just getting used to the little tiny ins and outs, the boundaries and the limits and all that kind of stuff. Okay. Now I want to get into the next part of this. Not yet. Yeah, I haven't told you what those words mean yet, so I figured I should do that first. But you guys lost there. So we're about to get into our, I like to introduce the symbols that we're going to use in a nice, easy way. Sometimes students take it as, why would you make such an easy idea into something difficult? Oh well. I'm trying to introduce the symbols to you. So tell me in English. Actually, let me do this first. I wanted to turn this around, but I think we're going to do this the other way. Let's do that in a minute. That's going to be the measures of center. But I do think I want to do this other thing first. Have any of you guys ever taken the SAT test? Anybody? Okay. When you get the results back, how do they give you the results? Do you remember? They put you into certain groups. Percentiles. Right? I don't know if you guys remember. So you're like in the 80th percentile. If you're in the 80th percentile, for example, does that mean that you got 80% of the test right? Or do you even know what it means? We're going to use this symbol to represent 80th percentile, P80. It's math people, we don't like to write a lot. Some of us can't write worth much. So it's better to use less. Thanks for agreeing so quickly. So, yes?
Does that mean you scored higher than everything?
Yeah, good. So if you're in the 80th percentile, you scored better than 80% of everybody else who took that test that day. Now, for a test like the SAT, why does grading it like that make sense? Is the SAT always the same? If it was, it'd be really even easier to cheat on it, right? So they're constantly changing it. And couldn't they arbitrarily change it? They try to keep everything the same, but make it a little harder than it was before. So then everybody's going to do a little bit worse. But if I grade you relative to how everybody did, then that's going to be consistent. I don't know if you guys understand. If you got in the 80th percentile and then make a harder test so everybody does worse, you're still at the 80th percentile. You still scored higher than 80% of everybody else who took that test on that day. So percentiles are a more relative way to measure things relative to everybody else who took that test. Are you guys semi with me? So 80th percentile does not mean you got an 80%. Right? In fact, you could be in the 80th percentile and have gotten 2 things right on a test out of 50 questions, just because everybody sucked at it. Right? Does that make sense? So for example, the first test I took in grad school, I got 14 out of 50 right. And I thought, well, this is a sign. Maybe Jeff doesn't. The teacher said later, he said, good job, Jeff. I'm like, what the hell are you talking about? Because everybody sucked on it. He expected people to die on it because they just make that first test crazy hard. I'm like, oh, the highest grade was like a 15 and I got 14. I'm like, sweet, I guess. Shit. So 80th percentile, let's investigate this. I'm not going to just give you the formula. Let's see why it makes sense what we have to do. Let me make up 10 numbers here. Should be exciting. Okay, let's see what I got. 1, 2, 3, 4, 6, 7, 8, 9, 10. Sweet, I like it. So say these are grades on a 50-point quiz. Right, there's 10 students left in the class at this point. I'm sure you've all been in classes like that, where it just dwindles and dwindles until you got 3 people left at the end. Maybe not 3. What would be your guess for what quiz grade is the 80th percentile? 42. All right, so I got a guess of 42. Say again? 27. 27? All right, so I've got a guess of 27. 27?
39.
I got a guess of 39. Okay.
46.
I got a guess of 46. Sure. If I keep going, maybe everybody. But real quick, to be really evil, nobody's right. But let me show you why you're not quite right. Now, this is a little evil question, really. 80th percentile means that 80% should be below you, and 80% of 10 people is 8 people. So 1, 2, 3, 4, 5, 6, 7, 8. So it seems like that would be the right answer. But it isn't. Because if you're in the 80th percentile, how many should be above you? 20%. 2 people, right? So 1, 2. So now it seems like that should be the right answer. And in a way, they're both right. But what's the one number that has 8 below it and 2 above it?
44.
Beautiful. It's got to be the average of these 2. So P80 for this list of data would be 44. Now, a couple things. P79 is also 44. P81 is also 40. There's only 10 data points up here. So percentiles don't make a lot of sense truly when the sample is so small. Let me let that sink in a little bit. If I had 100 data points, then the percentiles would kind of line up really beautifully. But if I only have 10 data points, there's going to be a lot of repeats. There's got to be. So let's see what the algebra is behind this. The very first thing I want to do, and why does this make sense? If I go 80% of the way into the list, that should be at least close to the right answer. Because what does the 80th percentile mean? 80% below it. I like it. I like it. So here's what happens. Let's try to do this algebraically. And I disagree a little bit with the way the book does this. I'm going to show you some simpler ways to do it. So what I do is if I want the 80th percentile, there's going to be a 2-step process. The first step is where's the answer, and the second step is go get the answer. So if I do 80% of 10, hopefully you guys know the algebra. It's your incoming prerequisite skills. 80% of 10, so 0.8 times 10 is 8. If you get a whole number, you average that with the next one up. So I got the 8th number, so I'm going to average that 8th and 9th number. And that matches up with what we just got. The 8th number is 42, the 9th number is 46. I average those together, so then P80 is 42 plus 46 divided by 2, 44. All right, what if you don't get a whole number? So if you get a whole number, you average that one out with the next one. Well, the 8 is when people get 8 and they circle 8. No, 8 has nothing to do with the answer. It's like where the answer is, roughly. So that's why I said the two-step. Where's the answer? Go get the answer. It's the average of the 8th and 9th. We go get those, 44. So let's try one that's not going to be quite that nice. It's not going to come out to a whole number. What if I wanted to know what do you got, Jeff? P 75. Sure. So what's the first step going to be?
And 75% of 10.
75% of 10. Go 75% of the way into my list. That makes sense for the first step because I'm bypassing that many people. I'm getting close to the answer. So what is 75% of 10? 7.5. Now, is that a whole number? No. Whole numbers, you average that one with the next one. Anything else, you round up and take that one. So if I got 7.1, 7.2, 7.396, 7.000004, I would round up to 8. And that's the answer. 8th number. So what's the answer? What's the 8th number?
42.
42. Just happens to be the answer to life, the universe, and everything, but here it's P75.
Oh, not that.
So again, the steps themselves make sense because they correlate to what percentile means. If I want the 80th percentile, I want to go 80% of the way into the list. So if the list was 38 numbers long, I would have done 80% of 38. The only reason there's a 10 here is because there were 10 numbers in my list. So this number will change depending on how long your list is. But if the 80th percentile means it's the number that has 80% below it, then going 80% of the way into the list makes sense. That's the step 1. Step 2 is a little adjustment we make. What kind of number did I get? If it's a whole number, you average it with the next one. Anything else, you round up and take that one. All right, let's try another example. You guys finish copying that down. And the reason I disagree with the book is they make it extra complicated for no real reason. Percentiles aren't an exact science, to be honest. I mean, there could be a lot of repeats in my data, and there's different ways to take care of the repeats. All right, let's do another example. Let's see. Where we go. All right. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Sure. And then one more. 14. I like it. So let's find, first off, P25. Now what's another way I could reference P25? That means how far into the list do I want to go? A quarter. So I can also call it, and this is the symbol we use, Q1. It's like the first quarter of a basketball game. That means you're 25% of the way through. Right? Of course, the last quarter takes twice as long as any other quarter, but we'll get past it. So another way to reference P25 is Q1, the first quarter. You could also break down like P10 as D1, the decile, the first step. I don't do all that crap. I just do percentiles, quartiles. That's as much as I worry about.
So do I do 87 or 91?
Well, let's find out. You ready? What are the two steps? First step?
The percentage.
Good. 25% of what?
14.
14. I think I made 14 data points, right?
Yeah, 14.
And what's
3.5.
3.5? I like it. Is that a whole number? No. So then you round it up and you take that number. I like it. Round to 4. So the fourth number is the answer. So the answer is 1, 2, 3, 4. And what about P50? What would that be in terms of Q? Yeah, Q2. It's also given a different name. It's called the median. It's the number that's right in the middle. P50, it's halfway in, so it's halfway from either side, so it's right in the middle. We call that the median. So again, the two steps would be 50% of 14. Well, half of 14 is 7. That's a whole number, so what do I do?
Average it out.
Yeah, the 7th and 8th averaged. So that means that P50 will be 1, 2, 3, 4, 5, 6, 7, 8. The average of 107 and 109?
108.
108. That's crazy. Okay, I like it. I like it. If you're following the pattern here, what do you think I'm going to ask for next? That's crazy. And of course, that would be Q3. Now watch, let me see if you guys get this. I could do 75% of 14, do all that work, or I could realize P25 is going this way. P75, I can go this many numbers in this way. Does that make sense? Either way you do it, it's going to come out with the same number. So sure, you could do, I'll do it this long way. You could do 75% of 14. And what is 75% of 14? 10.5. Right? Think. Don't trust. Okay. Round it up to 11. So the 11th number would be the answer, right? What's the 11th number? It's 1, 2, 3, 4 numbers in. So I could have just went 4 numbers from the end. If P25 is 4 numbers from the beginning, P75 is 4 numbers from the end. Symmetry. Okay, good. There it is. I like it. Just a shortcut. So where was it? 147. Now real quick, the work wouldn't change. I did these 3 specifically for a reason, to introduce these symbols, but also to do the next idea. I could do P32, I could do P69, I could do P07. The work wouldn't change. Are you guys with me? P7 would be 7% of 14. Get the number. Is it a whole number? Is it something else? The work doesn't change. Another reason why I did these 3 specifically is they're part of what's called a 5-number summary. And you can create what's known as a Box-and-Whisker Plot. Not my wording. It's the real wording of it. What's the lowest number? 80. And what's the highest number? 160. So that would be like Q0 in a way. And that would be like Q4 in a way. You guys with me a little bit? So that's Q0, Q1, Q2, Q3, Q4. That's what we call the 5-number summary. Yes, sir.
For the sake of argument, let's say like P75 comes out to like 10.4. We still round up to 11.
Yeah, always. So like I said earlier, 10.000004, rounded it to 11.
Okay, cool.
Yep, cool. The only time you average is if you get an exact whole number. Then you would average that with the next one. Okay, I like it. So a box and whisker plot is, believe it or not, I don't know. I was about to say it's exactly what you would think, but I don't, it's going to involve a box and it's going to involve whiskers. So that's why I call it box and whisker. And again, just to point out, this is new to you, but is the computation, is the actual mathematics behind this difficult? No. It's just new. The terminology is new. If I say find P17, you got to remember what the hell that means. Right? But the actual work behind doing it, not very difficult. Of course, this is brand new to you, so you've got to let it sink in a little bit. Do this for me. What kind of scale would I create if I wanted to include all of these data points? 80, 87, 108, 147, 160. That's pretty easy. From 80 to 160 I can go, right? And maybe I can go by, let's say, tens. Okay. Notice something. Scale is almost always, to some degree, independent from the actual points you got to plot. You just have to pick it so that there's a place for every point to go. So the people make mistakes about scale. They try to make the actual numbers show up here. No, you just make the scale consistent, and then you plot the numbers where they go. Now watch. Don't put a little circle. Don't go back to algebra. We're in stats class now. Put a line above each one of these. So the lowest one is 80. So put a line like right there. See that? Right at 80. Put a line at 87, roughly. Put a line at 108. 147, and then 160. The middle three, I'm going to box off. And then the outer ones are going to be my whiskers. This is a standard way to show how things are distributed. What percentage of the data is in the box? What's in the box?
25.
What percentage is below this? 25, right? 25% below that. What percentage is below this one?
50.
No? 75? So how much is in the box then? 50%. It's the middle 50%. And if you ever look at, has anybody ever heard of the Princeton Guide of Schools, like Princeton College Guide? If you're starting to wonder about where to transfer, right? They tell you the middle 50% GPAs, the middle 50% SATs. Graphing out a box and whisker plot is a quick way to see differences between two populations. So let's say this is a 160-point quiz I gave, and another class had this distribution. Which class do you would you say that the students were more consistent? Which one would have more variation amongst the grades? Let me say it like that. More variation amongst the grades. The first one. It went from 80 to 160, and the middle box is huge. 50% of the students scored between 87 and 147, whatever the hell those are. Right? So here, there's much less variation here, 50%. It's a much tighter little area in there. You guys see that? Which class seems to be the better class, possibly? Yeah, I'd say this guy, the second one, right? Nobody scored that low. The middle 50s here. Now, you would argue maybe there's a huge group here. What percentage scored between there in that class? You can't tell, let me just say, before you guys tear your hair out. There's got to be, no, you can't tell. I have no idea. All I know is from here to here is 25% of the data, right? That's between P50 and P75. Where are they? I don't know. They could all be right here. Or they could all be right here. More than likely it's some kind of a mixture, but I don't know. I've lost information. I only know percentages, how they fall. So, of course, it's not a complete account of all the data because it's a really quick, little, simple thing you can make. It's not going to be that perfect. But it's still you can still make distinctions between groups. That's the important thing. There are problems in the homework that have you making distinctions between groups. Okay, so you'll see that. So if I ask you for the 5-number summary, just remember it's basically all the quartiles. The lowest, Q1, Q2, Q3, the highest. It's the quickest way to kind of summarize where things fall. I like it. What would you say if you saw one that was like this? There's at least one person, right, that got everything right, but then based almost the entire rest of the class. What percentage of the class is in here? 25. What percentage is down here? 75% scored less than, holy shit, that's bad. I mean, so you see there are big kind of overall ideas you can get, but it's not like drilled down, you can tell really specific things, but this is just a quick way to get a feel for a population. And that's why we look at GPAs, the GPA from one school to the next, who they admit, the SATs, who they admit, right? Okay. It's like you're fighting to get in somewhere. Please give me that $20,000 bill. Let me fight for that. A chance to get so many loans racked up. I remember when I paid off my student loans, and still not that far back in my history. I had $30,000 racked up by the time I finished grad school in loans. Yay! So, thankfully, it's a very low percentage. All right, is that decent? Again, it's just a matter of getting there and trying it out. It's not, the calculations aren't that difficult. All right, so the last thing for today. Today's been packed, and I'm going to keep going. It's crazy. Last thing for today. It's the idea of measures of center. So the word average that we use in everyday life isn't really precise enough. There are many things we consider to be the average of a group of data. When we say average in real life, in everyday life, what we really mean is what's called the mean. And can somebody tell me in English how to find the mean of a set of data?
You add it all up, and then you divide it by the amount of things that you added up.
I like it. So add them up. Divided by the number of things in the list. How's that? So that's the English, right? Or the, pseudo-English. Here's the math. Math likes to make things very compact. So we have a single symbol that means add up all these things. And that symbol is the Greek letter sigma, capital sigma. Lowercase sigma is going to be even more important than this guy. So that means add them all up. But add up what? I have to put something here. And if I had a list of data, 4, 9, 12, 16, blah, blah, blah. What would I use to represent all of the values at once? Well, what thing do we use to represent a bunch of values? In algebra, we use x. So that means add up all the data values in my list. See why math people like that? It's a whole freaking sentence in 2 symbols. We love it. But then for math students, you just have to learn how to translate shit. Right? And thankfully, the letter we use for the number of things is n. That kind of makes sense. N is always going to mean the number of things in our group, be it a sample or a population. Now, the book likes to use a capital letter N for population. Whatever. Just N. N is the number of things I'm looking at. But there is a distinction to be made. I use the symbol mu, right? If you normally joke about it, it sounds like a French cow, but mu, so U with an extra leg on the front. If you make it an M, I understand. But try to make it distinct from an M, right? It's a little mu. That would mean a population mean. So very often for population we use Greek letters. Sort of like, except for the last Super Bowl. What the last Super Bowl was which Super Bowl was it? 50th, right? So before that, didn't they use big Roman numerals that would fall down? They'd have a graphic as if they're made out of stone, right? Because in Roman numerals, 49 would be XXXIN. That says the Super Bowl, you know. So for the 50th one, it would have just been the letter L. Beep. L. Right. So they're like, screw this. But in statistics, what we do is to make it, a population is like, whoa, population. So we give it Greek letters to give it a little more gravitas, right? Ooh, Greek letters, population. For sample, we just use X bar. A little bar over a letter means the average of that thing for sample.
What about sample population? Like sample of a population?
That's what sample means.
Oh, right.
Sample is a group from the population.
Oh, I thought we were talking like human population for some reason. Right?
Oh, well, that's one application of population. All right. Now, this is not the only measure of center, because, for example, if I went to work at some company and I asked people, how much do people make here on average? And let's say that, now this is in thousands. Let's say there's 3 employees there currently. One guy makes $45,000. Somebody else makes $48,000. Somebody else makes $56,000. And then you got the boss that makes $450,000 a year, right? Just to kind of mimic the actual gap there is nice. We won't get into politics because we're on screw that. Can you take a minute and figure out what the average salary is here? The mean salary, let me say, because the word average again is a little bit vague.
150,000.
Sweet. Is that? I'm trying to make it something nice. Does it come out to be 150,000?
149.7.
Oh, okay. 149,000. $750. All right, I like it. Just double check that.
Yeah.
All right, cool. I like it. That would not, if you told the guy, yeah, about $150,000, that's how much we make here on average, is that really being honest? No. Why is it so far off from the number you should tell them? Because, yeah, the outlier. Outlier. The 450. Where else do outliers occur, especially here in San Diego, or maybe towards the coast? La Jolla, I'm thinking about. What other outliers exist?
Coronado.
What are we talking about?
Real estate.
Real estate, housing, right? So obviously you can get millions of dollars of property out there in La Jolla, but then you move it a little bit inland, is a little bit more affordable, in which case it's still not really affordable. So the better average to use is what's called the median, the one that I mentioned earlier. The median doesn't give a shit about outliers. It just says what's in the middle of all the numbers. It's not affected by the values of the numbers. So in this case, the median would be small enough. It's 4, so it's going to be between the second and third, right? I mean, right here. So what the median would be 52. So see how these are 8 apart? So the middle would be 4 up from this, half of that, so 52. So if you told me, yeah, we make about $52,000 here, and that's much more honest. So that's why all the time, if you ever, you know that newspapers still exist? Or if you hear reports, wherever you get news from, and they talk about the housing situation, they always report the median house price, the median income, because it doesn't get affected by extreme outliers that exist in it. So these are both attempts to measure the center of something. All right, there's 2 more ways to measure the center of something. This is the median. The median, actually, let me show you. The median symbol is X with a little tilde on it. It's like a mean that got roughed up. Got his little hat all crooked. Aw. So x tilde, that's the symbol for the median. Another way to describe the center of something is called the mode. And it doesn't have to be the number occurring the most, the data point. Let me make this more general. Data point occurring the most. Because the mode is the only measure of center that works for qualitative data. Everything we've been doing so far, I can't take the average of something that's not quantitative. Because what does qualitative mean? What is qualitative data? It's got a quality. It doesn't have a quantity. It's non-numerical. It's not really numerical. Number operations don't make sense. So I can't take the mean hair color, but I can describe the hair color that occurs the most. Right? So this is the one measure center that works for all kinds of data. For us, we're going to mostly see numbers. So something simple would be, what's the mode there? No way. Oh. So obviously, what's the mode here? There's no mode. Right? Nothing occurs more than one. There's no mode. There's like a tie. 4 ways. We call it no. It's no winner. 4, 5, 6, 6. The mode is 6. What about 4, 5, 5, 6, 6? What we call bimodal. I love it. Just like bicycle. Bimodal. 5 and 6. And there's trimodal. Right? And then that's basically where we're like, screw it. If there's more than 3, there's not really a center. You can go to polymodal, but to be honest, that doesn't make any sense. Polymodal, like polynomial. Oh, shit. Right. What about 4, 5, 5, 6, 6, 6? 6, good. Not 5 and 6. There's a clear winner. 6 is the winner. So I'm not just saying which numbers are repeated. I'm saying which one occurs the most. So in this case, it'd be unimodal. Just one mode. 6. Yes, sir.
Does the mode have a symbol too?
No, it doesn't. One year we made a symbol up for it. I think we just made it capital M. Was the mode. So if you want to make a symbol up for it, what symbol would you like? Little dollop of ice cream. I was thinking about pile of mode. No symbol. You just use a word mode. It's fine. A fishbowl. What? Depeche Mode? What? How would you do that? No Depeche Mode. And then the last way to find the center that I want to talk about is the mid-range. This one's a little bit evil. Because do you remember what was the range? Yeah, the range is high minus low. The mid-range is exactly what it says, the middle of the range. So I want to take the high, the low, and how do you find the middle of 2 numbers? Average them. So the mid-range is going to be high plus low divided by 2. That sucks. People get so used to minus, they put a minus here also, but that doesn't make any sense for the average of 2 things. It's got to be the middle of the range. That's the mid-range. I like it. So you got mean, median, mode, mid-range. A bunch of M words made by math people. Cool. I think. Yeah, cool. Oh, yeah, that's right. Okay, we can do that. All right. I personally think that's enough for today. What do you guys? I think you're like, yeah, about 30 minutes right now. Don't forget quiz this Wednesday, chapter 1 in section 2-1.